Hey everyone, my name is Chris Walgamot. I'm a Senior Project Manager at NEA, Northwest Energy Efficiency Alliance. Welcome everybody to our Ask the Expert webinar on what one-for-one replacement means for energy savings and light quality. So I'm going to give it probably maybe 30 seconds and see how many more people are joining. Just let you guys know we're moving on with this in about 30 seconds. All right, great. I think we're going to get going so that we can get through all this and hopefully have lots of questions at the end. So again, everybody, my name is Chris Walgamot. I'm a Senior Product Manager with Northwest Energy Efficiency Alliance. And this is the Ask the Lighting Expert, a webinar on one-for-one replacement and what it means for energy savings and light quality. So thanks for taking the time to join us today. We hope everybody is staying safe and healthy. So there's a lot of buzz right now out in the world on luminaire level lighting controls and how they work, what they do, and how they sort of tie to energy savings, but also how they tie to projects in general. So we're looking today, I'm going to be joined by our research partners from the University of Oregon to share the results of the new study that demonstrates how luminaire level lighting controls can deliver both quality lighting and energy savings without the big price tag, and hopefully answer some of your questions. So first we're going to look at our agenda. Pretty simple. We're going to talk about what LLC is and why we decided to do this study. And then I'm going to turn it over to the folks from the U of O, and they're going to tell us how they did the study and the results that came from that. And then we'll have the conclusion and question and answers. So before we get going, just a couple housekeeping items. You've all been automatically muted as you entered the webinar. However, we are welcoming all questions. Please use the question feature on the GoToWebinar panel to send these our way. We'll answer some of the questions as we go along if we feel like they're important and pertinent, and if not, we'll answer them at the end. But definitely send them in as you have them so that we know what you're looking at. All right, so who's here for us? Again, my name's Chris Walgamot. I'm part of NEA, and I've been in the utility business for about 23 years now. I'm specialized in lighting. I do all the lighting for NEA and work throughout the industry, working with manufacturers and distributors and other utilities on lighting and lighting controls. So I'd also like to introduce Dr. Kevin Van Dien Melenberg. He's the Director of Energy Studies in the Building Laboratory at the University of Oregon. He serves as a professor of the architecture and a professor of architecture and a director of the Institute of Health and Well-Building Environment. His experience includes consulting on several hundred new construction and major renovation projects focused on daylighting and energy in a building since 2000. He's also published dozens of research papers and regularly presents at industry events. We are also joined by Alan Mayek. He is a research associate at the University of Oregon Energy Studies in the Building Laboratory. His work includes energy efficiency research, technical assistance, and outreach, and he has supported hundreds of research projects over the past 8 years. So thanks, guys, for joining us. We're going to hear from both of these guys in just a little bit, but first you get to listen to me a little bit longer, and we're going to talk about what LLC is. So, for those that don't know what LLC is, basically what we're defining here is it's a lighting system consisting of one or more luminaires that has embedded sensors in the fixture. And those sensors are capable of daylighting, occupancy sensing, and they wirelessly connect with all the other fixtures in the space. And all the fixtures have those sensors in them, so that it makes this network of lighting systems that have granular data and allow for a much finer look at the space and how we look at things. When we look at the capabilities, across all the LLC systems, they have these capabilities. So they're required to have occupancy sensing, daylight harvesting, continuous dimming, high-end trim or task tuning, and controls persistence. I think most everybody probably understands all those. The one that may jump out at people is controls persistence, which is a thing that utilities are very interested in. It's the ability for those fixtures to require that if they lose connectivity with any of the other fixtures or with the main server, that those fixtures revert to an energy efficient savings mode, whether it means that they're the last preset setting or one that's already defined in there, but they go to an energy savings mode, so they don't go to an all on back to the worst case scenario of full power all on type of thing and no controls. The other one that we'll talk a lot about in this case is the high-end trim or task tuning. That one is important in that it allows you to lower the highest point of the fixture's power. So if it was a 30-watt fixture and you trim it 50%, the most that fixture would use is 15 watts. So these are all the capabilities that are required as a base for everything. Inside of those, we have sort of the added benefits or added capabilities, which are in the next slide, which show us the advanced capabilities of some of these systems. Not all of these are capable in all systems, but they are capable in the majority of the systems. And that includes asset tracking, space utilization or optimization, building integration. So then you can use these to tie with your HVAC systems or other systems inside the building, demand response capability, and the ability to control plug load. So all these are advanced systems that are part of LLCs. Some have all of them, some have some of them. When you get into it, if you move on and you're putting some of these in, it's always important to know which pieces of this of the system you're installing is capable of. For this particular study, we didn't really touch on any of these. We really were focused on the ones prior, the base systems, so occupancy, daylighting, and task tuning. So why LLC? What we found, and the study will show a bunch of this, is that we see energy savings, pretty substantial energy savings, depending on the building type and use case, up to 75% energy savings from the controls. We see flexibility and future-proofing with the systems, because every fixture has a sensor in it, and every fixture is controllable down to a end node of that fixture, but not necessarily giving individual control to the person. You have the flexibility to create bigger zones or bigger groups or scenes, and it just allows for changes in the future without big expense. One of the things that we were looking at is we think that the quality of light and the aesthetics are much better with these, because you're getting to control, again, down to an individual fixture if needed. And part of that will translate into occupancy, comfort, and productivity. Once we get into these, you'll see that the installation is relatively simple. I think that the nice thing about it is most of these systems are using some form of handheld control, whether it's a remote control that's separate or a phone or an app that allows you to control all the functions of these lights from a simple point without having to go into a major computer or get on a ladder and get up to them. The other nice thing is that LLC is basically energy code compliant right out of the box. So those are the reasons why I think LLC is sort of the wave of the future for lighting control. And so just so everybody's aware of what we're defining one-for-one lighting retrofit, is that the general lighting that is placed without moving or changing the number of fixtures or the place the fixtures are installed. So you literally walk in, there's 15 fixtures, you pull 15 fixtures out, and you put 15 new fixtures in the exact places without moving or touching anything. This is usually the simplest of the lighting retrofits and the least costly because you're not having to move any wires or change anything. So there's pros to it and there's cons to it. Again, no additional wiring, no moving the fixtures, no design work needed. The cons are that you're possibly under or over lighting the space with these new fixtures, or the quality of light can be questionable because it may not be designed in a way that the new space, if you changed from the original design of what the layout is of the workers, it may not be great. And it limits the flexibility of the customers. So these things are what we're defining as one-for-one retrofit versus a redesign where you may go in and move fixtures or change the type of fixtures or add fixtures or remove fixtures and that kind of stuff. So the next slide, I think we're going to talk about why we did this study. And so the big thing is that, one-for-ones don't necessarily give you the best energy savings when it comes to lighting retrofits. So we wanted to know if with LLC, if you did a one-for-one lighting replacement, could you see quality lighting and energy savings that are equal to or close to equal to a full lighting design, redesign? And if so, what's the cost difference and how do those savings come about and where do we see them and how that works? We wanted, for the utilities, this is a big deal because if we can promote one-for-one replacements with LLC and we get equal to or almost equal to energy savings that comes from a full redesign at a portion of the cost, then that's a big promotional thing for them. It's a good thing for them to be able to have that in their sort of their pocket of knowing that these systems can provide great energy savings. And it also provides, and implications across all stakeholders, from the building owners to the operators to the manufacturers to the utilities, provides great influence on how we start to look at lighting retrofit jobs going forward. So I think at this point, I'm going to turn this over to Alan and Kevin and let them start talking about what the findings were and how things turned out.
All right, well, I'll start and just say that the study design that was set out was really trying to ask these questions about lighting quality and energy savings relative to a baseline design, which Alan will explain here in a moment, as well as relative to other one-for-ones. So we tested multiple one-for-ones. And then, of course, we also did the redesign solution, which Alan will explain more. And we'll start to unpack this. But just to kind of hook you all with the major takeaways so that you can maybe better understand the context for then which the methods will unpack. The energy savings were substantial. For both for all of the solutions, all the one-for-one solutions, as well as for the redesign solution. Actually, the savings were quite substantial over baseline. More than 50% lighting energy savings, as much as 75%. People liked the one-for-ones. They also liked the redesign, but they liked the one-for-ones much better than the baseline. They liked the one-for-one solutions, the LLLC one-for-one solutions, quite similarly to the redesign solution. And the study that we did, looking at 4 one-for-one LLLC solutions, 4 different manufacturers, and 1 redesign solution, and just looking at those cost differentials, the LLLC one-for-ones on average were about 1/3 of the cost of the redesign solution. So with that said, as a kind of intro, Alan's going to unpack the methods, and then we'll start to pull those results apart a little more detailed at the end, and also have some dialogue about the benefits, the limitations of this study, and try to put it into some context for the general application. So with that, I'll turn it back to Al, or turn it over to Alan.
Sure. Thank you, Kevin. So with that, let's look at the study design and methodology here. The study lab space is located on the University of Oregon campus in Eugene. It's an 891 square foot space, 33 feet by 27 feet, with a 10-foot ceiling with the white drop ceiling that you can see in the photo there. We have 3 windows on the north facade, 10-foot head heights. Each one's roughly 6 feet wide, and then a 3x3 grid of 4-foot indirect direct pendant luminaires for a total of 9, and those are dropped about 2 feet from the drop ceiling. In the center of the space, we have 4 mock-ups of open office workstations. We didn't include any partitions, so in a sense, this portrays sort of an ideal case when it comes to lighting distribution for this test. This next slide here is going to show a 360-degree scan of the space, just to give you a sense for what it looks like from that first workstation, workstation number 1. And so 6 total cases were tested, starting with the baseline in the top left there that you can see. These are dual 32-watt TA fluorescent bulbs in a 4-foot indirect direct pendant case, luminaire case. The 5 test systems, 4 of them were LLLC or representative of LLLC 1-for-1 retrofits, and 1 was the redesign that we compared it to. So 3 of the 1-for-1 systems included what we called a clever system, and in this case that's defined as a one-way networked communication through a simple driver. The 4th 1-for-1 system was essentially what we call the smart system, and this one is a 2-way communication, which links to a network lighting control system, BAS system, that would allow changes to be made based on feedback from that system. And lastly, the 1 redesign system was also one of these smart 2-way communication systems, so we wanted to get that variety in there. The fixtures specified, again, were kept as consistent as we could. They were all 4-foot indirect direct linear pendant LEDs, so operates from the fluorescence. But as you can see in the photos, they're all roughly 2-foot drop height, with some different design and form factors. So that introduced a little variance, but again, it depends on the manufacturer and the system. One more thing to mention here. So all 5 of these test systems were chosen from the Design Lights Consortium Network Lighting Controls Qualified Products List, and our selection criteria included system complexity between install and programming, intentional variety of the system features as per the DLC criteria list and ESBL discretion, and then cost of hardware and install. Market presence and impact was another one, and lastly, industry feedback, so from lighting designers and architects. Luminaire specs were kept as consistent as possible across input power, lumen output, color temperature, the indirect direct ratio, the CRI, and controls dimming. The installed LPD ranged from 0.32 to 0.36 watts per foot squared, while the baseline sat at roughly 0.6 watts per foot squared. Systems were tested sequentially in 3-week periods between winter of 2018 and spring of 2020. So these are some of the primary variables that were standardized for the commissioning and tuning of each system, and these included auto-on, auto-off controls with occupancy timeouts of 15 minutes across the board. Daylight harvesting, the minimum ranged between 0 and 5% depending on system capability, while the maximum for all of them was 100%. Tuning was based on the IES lighting handbook recommendations for standard for open office lighting level at the horizontal work plane, which was 300 lux. As a result, high-end trim ranged from 40% to 100% of the total output of each fixture. and this was based on the average illuminance that was measured at each of the workstations during commissioning and tuning. So we tried to balance those out with sort of a trial and error approach where we would take measurements at each workstation, the ones along the north facade included, and then try to sort of balance all 9 of the fixtures until we arrived at a reasonable error, which in this case was below 1%, I believe. And this slide shows the difference in design between the LLLC 1-for-1 retrofit and the redesign approach. So the 1-for-1 solution included individually controlled fixtures, as Chris described, with daylight harvesting and occupancy sensors embedded in the fixtures. And they were all controlled by a manual on-off override switch from the wall switch near the entry that you can see in the bottom left-hand corner of each diagram. The redesigned solution, on the other hand, used a zoning approach, which grouped luminaires into 3 zones. So we had the perimeter next to the north facade, we had the middle, and the core down along the south end. With the core zone, so the core zone fell outside of what we consider the daylit zone, and as a result, it only included occupancy switching and not daylight harvesting in this case, while the perimeter and middle zones had their own zones with their own individual daylight sensors. So both the daylight and occupancy sensors were ceiling mounted for the redesign independently of the luminaires, and occupancy grouping and sensor placement were optimized based on sensor coverage, overlap, lines of sight to make sure there were no issues. And in this case, we came down to 4 occupancy sensors with the 4 different zones that sort of overlapped as much as possible, and the 2 daylight sensors for the 2 daylight zones. And so alternative layouts, we considered alternative layouts for the redesign, but after consulting a professional lighting designer and performing lighting simulations and analyses of our own, we found that the existing 3x3 layout was still the most optimal for this space and how it's used. And in addition to budget constraints, we decided to maintain the 3x3 layout and then optimize the occupancy and photosensor placement instead. And here we'll be looking at a few variables we considered. There were quite a few. And this list shows some of the significant ones, which include illuminance, which we measured at the desktop that you can see by the photopic illuminance sensors on a 1-minute interval. We had energy logging above the ceiling, or power logging, with CTs. We had spectral data collection with the spectrophotometer that you can see in the back of the space. And I think that covers most of the important ones. And let's look at the human factors testing items real quick here. So the human factors questionnaires were made up of a series of questions that rated light quality, brightness, uniformity, variation, and discomfort. And some of the interesting ones that came up in our analysis are labeled here with the arrows, such as brightness of the visual environment, ceiling brightness, perception of light quality between these different word associations. So dim and bright, calming and exciting, and subdued and stimulating, with a neutral rating in between. We also collected some information about rating of alertness, lighting distribution at the workstation, and lastly, overall satisfaction with the amount of light that was available for the intended work, which in this case was computer and paper-based tasks, so vertical and horizontal-based tasks. Quick note on the sample sizes. So we ended up with 76 total subjects, 57% female, 43% male, and we had 183 total 2-hour sessions, with 79% collected from subjects aged 18 to 30, 17% were aged 31 to 45, and 4% were aged 46 to 55. So there's a bit of bias there on the young end, but again, this was conducted at the University of Oregon, so our primary source of participants were the students there. and a little bit on the analysis methods. So statistical analyses focused on difference of means between questionnaire items. So a t-test was used to determine if two systems have equal means for a specific questionnaire item, or rather if there's significant difference between those questionnaire items. Statistical correlations were used to look for significant relationships between the questionnaire items or responses and the environmental metrics that we looked at briefly there. Then linear regressions showed the strength and direction of those relationships. Luminance maps were used to measure light intensity in the visual field, as well as potential glare issues that might come up. And you can see an example in the bottom right-hand corner of this slide. And right next to it, to the left there, we have an example of some of the logged power data that was collected, and we converted this data, or correlated it rather, to exterior sky conditions at the time of testing, and then extrapolated that correlation to annual weather data to estimate annual lighting energy savings for each system. And now we'll dive into some of the study results. So I will take a look at the costs here real quick. So the table shows all the detailed costs that we found for the hardware total, luminaire per unit, labor, design spec, and then the total cost and the total per square foot. So these came down to $6.04 per square foot to $7.44 per square foot for the LLC 1-for-1s, while the redesign sat at $17.57 per square foot. So roughly a third to a half of the cost of the redesign. And I'll just set up this table here for Kevin. So what we're looking at is a breakdown by system in the rows, and we have 3 columns of data here. So the one on the left here looks at savings due to all of the controls measures, which includes daylight harvesting, occupancy sensing, and high-end trim. The next one over in the middle looks at only daylight harvesting and occupancy, and then the far one on the right looks at savings due to high-end trim only.
All right, so we'll stay on this slide for just a moment. There's a lot of information here, so we'll actually try to pull this apart a few different ways in the subsequent slides. But just to kind of highlight the 3 large text vertical columns, savings from all control measures together being in the first column furthest left with the large numbers. You can see the 4 LLLC 1-for-1 replacements were the first 4 rows. So savings over baseline ranged from 50% to 74%. So substantial savings over the T8 baseline. Perhaps not surprised, at that 0.35 watts per square foot average installed. And it's right in the ballpark with the total savings from the redesign solution. Some a little higher, some a little lower, but on average quite similar. The second column, savings from the kind of operational day-to-day variable dynamic measures of daylight and occupancy. You can see that there is a bit of a difference between the redesign system. Actually, you can go to the next slide to highlight this. Sorry, thank you. So I'll actually present this first. So the first thing that we wanted to call out were that 2 of the 4 LLLC systems had pretty moderate high-end trim. They only reduced, they only saved between 6 and 8% energy savings from the high-end trim. So that is basically getting to that question of how many lumens are installed relative to what is required to meet the 300 lux or roughly 30-foot candle threshold for the ambient illumination from the IES. And it just so happens that these 2 actually had slightly lower installed wattage. So they were a little on the lower end of the installed lighting power density in the first place. There may be some dynamics with regards to lighting distribution, none of the fixture locations changed, and so we were using the same, the same desktop locations for the commissioning. But anyway, I think worth noting that some of the difference, the biggest chunk of the difference for the lower energy savings from those two solutions actually came from the kind of continuous burn, if you will, that we weren't able to trim them down quite as much as the other two solutions. Next column, or next slide. So to the point I was making about this middle column, pretty notable difference between the redesigned system at 32% savings over baseline relative to the LLLC solutions that ranged between 40 and 45% savings over baseline for that component. You add these all together, and that's when you get the first column of large numbers. So the difference here is really coming from the lack of daylight harvesting on the core zone. If you go to the next slide, I think we highlight all the core zone sections. So it's trying to explain that difference of why were we seeing a lower energy savings from the redesigned solution. And it really came from this kind of keep it simple principle, where what's inherent to the one-for-one solutions, what's inherent to the LLLC solutions is that each fixture is loaded with all the sensors. When we're doing the redesign, we have, in this case, we made determinations of where to locate occupancy sensors and most importantly, daylight harvesting. And you can see that the core zone was not saving as much energy for the redesign as it was for all of the LLLC solutions. And we're actually still working on trying to pull apart the occupancy data from the daylight data. All of this was coming from current transducers, and so it doesn't differentiate. So we're trying to use some smart overlays with weather data and occupancy patterns to try to pull those apart. But suffice it to say, a big piece of the difference is coming from that we were not doing daylight harvesting in the redesigned solution for the core zone. And that was just a determination made based upon kind of experience in the field that once you're more than 2 window head heights away from the window, and I think we were about 2.5 window head heights away for that center zone, we just decided not to apply the daylight dimming. Whereas the LLLC solutions they have daylight sensing on board, and they were capturing some savings from relatively modest amounts of daylight into that core zone area. So I think an interesting differentiation. I think it's a fair question about whether we made the right choice from a redesign. Nonetheless, it is what choice we made, and these are the results that came from it. I think maybe this is as good a place as any to just unpack one of these other questions. That high-end trim question is I think the column on the far right kind of gets to this one a bit. And the idea is with one-for-one replacements, you might end up with underlit spaces if you didn't have the right number of fixtures in there in the first place, but more commonly overlit spaces when you bring in new LED fixtures that maybe have more output or just a perception of greater brightness in the fixture design, which I think is getting better and better as we move forward, but has certainly been a historic challenge with the one-for-one replacements with LED solutions. The benefit there is with high-end trim and the ability to dial those down to the IES standards, even if you have it slightly higher installed capacity, high-end trim can bring it down such that you can manage the energy savings there and the potential for glare and discomfort. So with that, I'll actually transition to the next slide, which will help us pull apart the human factors work a little bit. So this is a really high-level takeaway from what is a fairly substantial amount of human factors research that is documented in the report. Available on the NEA website. But the high-level takeaway here is that the LLLC one-for-one solutions were consistently better than the baseline in terms of across the board, the various, the 15 or so questions that Alan highlighted earlier. generally the 1-for-1 LLLC solutions perform better than the baseline. And it's not a terrible baseline. It's a T8, 32 watt, 2 lamp solution. Troffer, kind of indirect direct with a little bit of a troffer design in it. The appendant fixture with a troffer design in, if that makes sense, the troffer reflectors. The second one is that, you might take this as a negative finding that the LLC 1-for-1 solution didn't perform better than the redesign, but really the neutral finding there is completely adequate. We didn't necessarily expect that the 1-for-1 LLLC solutions would outperform a redesign solution. So the lack of statistical significance there is basically saying there really is no statistical difference from a human factor standpoint for the redesign versus the LLLC 1-for-1s. So that's a win. It performs equivalently. So there was, as you can imagine, in any human factors study, you're going to see some people with more sensitivity to brightness and some with less. So it's very common to find some complaints around glare. This is a room also with daylight, though it's north-facing daylight, so only modest, risk of solar penetration, very limited solar penetration during the study design, or during the study collection period. Sometimes north skies can be glaring and cause, just that brightness of the sky, some contrast in the space. And it's not a space that was sort of fundamentally designed for daylight. So all that said, there were some complaints, modest though they were, around glare. And what we tried to do is determine whether those were fixture associated or not. And basically the results were inconclusive. Some of the glare appeared to have been fixture associated, but not a strong statistically significant signal. Some of the glare appeared to be daylight associated. And I would say in any population, there's always going to be about 15% of the population that has a greater sensitivity to brightness than the rest. And so that's kind of where I would attribute most of the comfort complaints to. And then the final point, the benefit of the tuning, I think, helped to mitigate some of the concerns we might have seen had we not done that proper commissioning and task tuning. I think it's quite possible that we would have seen more glare complaints had we not done that task tuning. So that's what's really important, I think, to take away with this LLLC 1-for-1 solution, is that it's a critical piece to the process. And I think there's always room for a lighting designer to improve the lighting quality of a space. Our redesign solution was actually a pretty vanilla, if you will, a fairly vanilla redesign. We didn't want to bias the cost any further by adding wall washers or any decorative lighting. So it's a pretty generic office lighting redesign solution. I think it's possible that a well-done redesign could outperform LLLC, but I think really the point with this study is it advisable to take the LLLC 1-for-1 solution to a broad scale market scale up? And I think the big takeaway from the human factors research here is there's no reason to believe that that's a bad idea. In fact, it looks like a good idea given the benefits over the baseline solution. Next slide. I just wanted to unpack a little bit about the commissioning and install process. I think this is an interesting nuance. The first kind of big takeaway here is that each of these solutions have different interfaces. And really it's a small application of about 900 square feet. And so we had the same commissioning and electrical contractor do the commissioning work for all the solutions. We did some bench testing ourselves ahead of time just to make sure that the solution that we desired was possible, but then we didn't say anything, and we basically gave the different setups to the electrical contractor, who's the university electrical contractor on staff at the university, and they did the install. And we observed and we tracked the hours, and we had a post-occupant or sort of post-installation questionnaire, which you see some of the results of here. And I think it's important to note this is kind of the hardest version of these installs. This is the first 9 fixtures where like the first space, that you go into in a major lighting retrofit and you're trying to figure it out. So this is the hardest and sort of most biased piece of the equation. You can see that there were some differences where some of the LLLC systems, you see the 3 questions there. Question 5 were substantially different than some of the other setups. And the question 5 is how difficult was the programming for the current fixture and system? So you can see, for example, system 2 appeared to be, the most challenging. And then for the redesign solution, it was the first question that showed a significant difference. Question 3, how difficult was the wiring required to install? They went in this order, so there may be some modest sequence bias. However, I would say that perhaps the bias would really be only against the redesign here, where the wiring was relatively simple for these one-for-one replacements, the LLLC solutions, whereas the wiring, because of the sensor locations, was a little more complicated for the redesign solution. I would say, all of that said, this is the most difficult slice of any major retrofit, that first setup of that first space. And I would say these differences likely come out as in the noise as you scale this to more square feet. Next slide. So just to kind of wrap up here with the conclusions, the one-for-one LLLC solutions showed 50 to 75% reduction over baseline and performed quite similarly in energy to the redesign solution. The one-for-one LLLCs had improved human comfort across the board relative to baseline and performed similarly from a human factor standpoint to the redesign. And all of that at about 1/3 to 1/2 the cost of the redesigned solution. Every study has limitations. These are a few. This was a single zone study, and I just got done describing some of those. But the other piece about a single zone, some of the challenges of a single zone study are that they're not very representative of sort of the wide range of perhaps current fixture densities within spaces. Some will go to 100 spaces, we're going to see much more variability. The fact that our redesign solution, through a fairly extensive analysis, kind of came back to the 9 fixtures in the space as being the reasonable solution would suggest that, there might be spaces that are going to be a little more challenging for the one-for-one solution with the LLC solution to fit into. I'd say with the caveat being that the sensors and the task tuning or the high-end trim allow for modulating some of that concern. There were short testing periods per fixture set. Each of them were installed for 3 to 4 weeks. We had to deal with the weather conditions that we had over the course of the study. When we annualized the energy savings, I think we did a pretty robust job taking those 3 or 4 week snapshots and turning them into accurate annual estimates. But nonetheless, they are short periods of study. And then, of course, the bias towards younger participants given the university setting. So with that, I'll turn it back to Chris to wrap us up.
Great. Thanks, Kevin and Alan, for going through that. We do have some questions to get to, but, I'm going to read off a couple of them that have come in. And if you guys have any more, please let us know what they are, and we'll see if we can get to them. We've got 15 minutes here to talk about some questions. So Kevin and Alan, first question in is the redesign approach used contained the same number of fixtures. Many redesigns, I think this might be a statement more than a question. Many redesigns result in lower numbers of fixtures fixtures and cost compared to one-for-one, which I think is totally true. But we did, on this redesign, I think you guys mentioned, we did have a lighting designer look at it, and they didn't suggest removing lights, but if they had suggested removing lights or adding lights or any of that nature, we would have done so at the time with a lighting designer looking at the space. Correct?
Yeah, and I'll just add, in addition, that's correct. In addition, we also did basically fixture lux maps through software simulation to see if we could optimize it. The trick was, can you get from 3 rows down to 2 somehow? and we just couldn't quite make it go and still maintain the IES standards.
That's
Not
true.
to say that it's impossible. Yeah.
Yeah, sorry, Kevin. Yeah, I would just add that I think light distribution and uniformity became an issue as well. So we did look at reducing the number of fixtures, but then again, we would have to increase the lumen output, which could introduce some non-uniformity in the space and some bright spots as well.
And I think we're all aware, and you know, we had no problems if things would have changed the design. It was kind of, I mean, my hopes when we first started this, that there would be some changes so that we would see that, rather it was removal of lights or adding lights or whatever. We wanted that. It just happened that when we went through this process, it didn't need that to happen. Okay, so
yeah,
the next question.
The only other, oh, sorry, yeah, I'll just finish real quick. You know, we looked at scenarios where we do more wall wash and fewer pendant fixtures and things like that. It started also pushing costs around where I felt like we were going to be biasing the data even more on a cost perspective. So,
yeah. The next question comes from Dan Mellinger. Do you have the cost for the controls separately from the fixture? So in that chart where we had the cost per square footage, that included the fixtures obviously in there, and pendant mounts are obviously a little more expensive fixture than say troughers that are put in place. Did you guys separate out the cost of the controls from the fixtures so you have an idea of that piece between the two types of systems? Or
I don't think we separated it out. It looks like we have a hardware total, which again includes the fixtures and any peripherals that came with it. So, you know, Wi-Fi hubs, any energy managers, and any other items that came with it. That is a good point. So
it's possible though. We have the data. We could we don't have it off the top of our head, and I don't believe we highlighted it that way in the report, but I think it would be possible.
Okay, and honestly, for NIA, just for the people that are on the call, NIA does has been doing a yearly study on the incremental cost of LLC versus standalone fixtures. So we do have some data on that out there as well that shows what the controls equipment for the LLC piece costs compared to a fixture that doesn't have it. So there is some incremental there. We don't have it against a redesign system, but we do have some on what the incremental cost for adding LLC to a system is. And we can get those reports out as well if for anybody that's interested. Next question is from Aaron Feldman. Do you plan to conduct a similar study in other environments, as many of these results may vary based on settings, warehouse, schools, retail? I'll take that one a little bit. I think we'd like to. One of the things that obviously right now, it's tough to do a lot of research right now with the environment we're in. We ran into that with this study as well, and another study that we're working on, that we had to cut short a little bit on this one because nobody was there. We couldn't. Not a lot of good information comes when school's closed and nobody can be in the space. There's a lot of energy savings that flows out of that. So, but I think it's something we're definitely looking at. We'd like to be able to do it in a different place, but it does come down to can we do it, and you know, also the big factor is money. Can we afford to do more looks at it? But I know that we would like to going forward. Next question is from Gabe Arnold. He says, I'm interested in any feedback regarding distractions due to adjacent lights turning on or off or dimming in the LLC solutions, where each luminaire is controlled by an occupancy sensor. Was this an appropriate space to evaluate this impact? How did the LLCs evaluated function in this regard? For example, did any incorporate a background, dimming, adjacent fixtures feature, or slow ramp rates to mitigate distraction? Did you understand that?
Yeah,
second.
I'll
I
just
know what
say
you're
I think
saying.
it's a really good question. I'm going to let Alan address it to some extent, but I would say that was one of my concerns going in, and it was also part of, I think, what drove some of our choices on the redesign to try to keep the daylight dimming simple. So with that, I'll cue up Alan and let him delve in a little more.
Sure. So we did include, I believe it was a pair of questions on our questionnaire, and it basically asked, did you notice any changes in the lights while you were working in this space? And then the other one was, were any of the lights a source of discomfort while you were working here during testing? And neither one came up with any significant correlations with any of the other metrics or data. However, what we did find was that they, for the most part, they answered yes, that they did notice some of the changes in the dimming and the occupancy switching, but that didn't correlate to discomfort. So that's a little bit of good news, but again, it didn't come up as a significant metric or finding.
Next question, kind of a twofer, came from Jack Seiger. Could you explain more about why the LLC solutions were actually less expensive? And if they are actually less expensive, why has there not been more uptake? So I think I'll let you guys talk about a little bit of it, and then I'll throw in my 2 cents at the end.
Sure. Yeah, I can really quickly mention just, I think it's the variety in components. So the redesign included sort of this more comprehensive system that also included more expensive peripheral items. So we had, gateway switches, Ethernet switches, an energy manager that ran the building automation system software, the light control software, whereas the LLC one-for-ones are more sort of neatly packaged and have a smaller footprint in that regard. Some of them included Wi-Fi hubs and gateways that enabled the lights to sort of talk to each other, and the app software to control them and commission them, but the scope of the software wasn't as broad as that redesign system. So
yeah, and I'll add a little more to it. I think part of it may be hidden in the size of the project, where this redesigned lighting solution would probably look more favorable with a much larger project. I don't think it's going to look more favorable than the LLC one-for-one replacements, but I think you would start to see that margin shift a bit, or rather, you'd start to see that margin close, and they would come closer together with a larger installation. The other piece about it is that the redesign had some enhanced capabilities that the one-for-one LLCs didn't have, most notably really the ability to do pretty substantial color tuning, spectral tuning, and to some extent, but certainly color tuning. And that was beyond the scope of the study, but it was sort of a built-in bonus with the redesign solution. So you can imagine, if you wanted to explore color balance with daylight, where the color temperature of the room starts to shift with variable daylight. We didn't have the sensors to do that, but you can manually manipulate the color with the current solution, the redesign solution, and you could imagine adding sensors to look at outdoor color temperature or spectral content and try to manipulate the indoor. So I would say the two pieces in my mind were they would come closer together with a bigger project, and then there were some enhanced capabilities in the redesign solution.
I'd say one other thing that, it's highlighted, but it does make a difference, and it's not always accounted for in this, is the wiring difference that's put in place between a system like an LLC system, where there's really no extra wiring for the controls because it's all built in. So it's still 3 wires, and then the power wire, power, ground, and neutral, just that's what it takes to wire the fixtures up. While some redesign systems are going to have 0 to 10 volt wiring, that they have to put in for the sensors. There's an additional cost that goes with that adds to it. So I mean, there's a lot of things that can add to it. I think in a lot of cases, when you look at that the product, like the fixture with an LLC or the sensor, that fixture tends to be a shade more expensive than one that doesn't have a sensor in it. But when you start adding all the other components for the system that doesn't have a sensor built in, it does add up pretty quick as to how fast they get to be more expensive. And as to why the uptake hasn't happened as fast, I think that's something that NIA is looking at really, really heavily. But I think one of the reasons is it's new and it's not normal compared to what lighting controls have been for the last 30 years, right? I mean, this is a completely different approach to how you do controls with your lighting than what's been in place. Regardless of wireless or not, the lighting systems and control systems that are in place have been a single sensor that controls multiple fixtures since the 70s. And that's what people are comfortable with and what they've seen. Even though, for the most part, people hate them or don't like them or they don't work correctly or they're whatever the other answer is, you can tape over them or whatever, but that's what it's been done. So there's a new approach with LLC where every fixture has a sensor and you're using, it's wireless and that kind of stuff is brand new, and it's a little scary and a little, that unknown right now as we move forward. But I can tell you that from what we've seen, NIA has been working on this on LLC for, about 10 years. We're definitely seeing an increase in the amount of people that are putting them in and an increase in the people that are interested in them. So it is definitely starting to come around. It's just taking a little time to get people used to it. So
one anecdote I'll share is that our electrical contractor had never seen them before. So that's to your point, Chris, they're new. And, this gentleman he's oversees lighting for, 50, 75 buildings on campus. He's got a lot of experience, and lighting retrofits are pretty common. So that was interesting. He had never seen them before, and he loved them. He was a little skeptical at first, but then he's like, wow, this is really fast. This is really easy. In fact, we thought we were going to use some of as we swapped out these systems, we thought, oh, good, we'll have some extra lights for some other research projects. And he's asked us to take all of them, and he's using them on other places on campus already.
So I think we're just about out of time. I'm going to give Andrew Patarek, he sent something in, and also on the dollars, cost, that was without any utility incentives. So anybody that looks at this, please make sure that you talk to your utilities about any incentives that are there, because they will help lower the cost on all this, even full retrofit jobs, that they'll be able to see, help reduce that cost on top of it, because the utilities, especially in the Northwest, have some amazing incentives in place for it. And Andrew sent in a comment about PSE up in Seattle area, that they installed LLC, 2 different systems, and didn't have any problems with that, what Gabe was talking about with the dimming of groups, and they saw the savings in the same range of upwards of 70% over a 3-lamp fluorescent, and they put an incentive in place. So again, Kevin, Alan, thank you very much for your time this morning, and thank you all for joining us. I hope this was informative. On the screen is where the full report lives, and I think you'll be able to have access to it and be able to read the whole thing. And if you have any other questions, please contact us and let us know. Thanks, everybody.